Yes, ma'am. Yeah. As we're going through a lot of the stuff that we've been looking through, guys, it's kind of been the same thing over and over and over again. One of the things that we always did, or we've done, first thing we'd had slopes. Change of y, we change an x. After that, we did, we talked about point slope form. Point slope form was the stuff that we did. Thank you, sir. Point slope was the stuff that we did when you had a point and slope. And that had its own form. Point slope looked like this. Or literally when you have a point and a slope, you use that. And then from there, you would put everything into what's called slope-intercept form. And slope-intercept form then was your y equals mx plus b. And that was our final setup through. And as we go along into the stuff today, what we're going to start with is worrying about parallels and perpendiculars. How you can be parallel through a point, how you can be perpendicular through a point, things like that. And it also kind of boils back to the idea of what does it mean to be parallel? What does it mean to be perpendicular? So when we're talking about things being parallel lines. What do you know about parallel? What do you know about parallel lines? They never touch. Okay. The reason they don't touch is because their slopes are the same. So parallel lines. Yes, ma'am. Yep. Parallel lines always have the same slopes. Yes, ma'am. Yeah. Parallel lines have the same slopes. And then perpendicular lines they have what are called opposite reciprocal slopes. Okay, opposite reciprocal. So parallel lines would be same slopes. Perpendicular lines would be opposite reciprocal slopes. Again, this is all a review of things you guys did back in Algebra 1. It's just, we bring it up again here because in geometry, you talk about parallels and perpendicular. So, what I always do with these style problems and whatnot is I don't want to say dumb it down, but I kind of follow the same procedures always. If you want to determine whether or not two lines are parallel or perpendicular, you just have to figure out their slopes. Find their slopes. If they're the same, they're parallel. If they're different, they could be not parallel or they could be opposite reciprocals. Now, reminder, opposite reciprocal, for example, an example of what's called an opposite reciprocal. If my original slope was 2/3. I use this terminology a lot, the original ORG, just to kind of show that off. That way we always know that's what you're talking about to start with. If your original slope is 2/3, what's parallel to 2/3? How about 2/3? You're right with 4/6, but isn't that just also 2/3? Parallel lines have the same slopes. Perpendicular then, what's the opposite of a positive? And flip the fraction. Opposite reciprocal. Change the sign, flip the fraction. That's what that means. That's it. Opposite reciprocals. Yep. One of the things that happens a lot of times, though, people forget, if your original slope, let's say is -2. If your original slope is -2, what's parallel to -2? -2. And then perpendicular to -2, well, what's the opposite? Hold on. Slow down. When we talk about perpendicular, first thing we do is what's the opposite of negative? Positive, okay? So it's going to be a positive something. If you have 2, what's the reciprocal of 2? 1 over 2. 1/2. Remember, what's underneath the 2 that you just don't see? And that's how that works. One of the things that you will screw up, because this is inevitable, what's the slope of a horizontal line? Slope of a horizontal line is 0. What's the slope of a vertical line? It's undefined. I was asking the slope, not the equation. The slope of a vertical line is undefined. Now, this is where you have to understand where all of this is coming from. Your horizontal lines is always parallel to horizontal lines. Okay. Horizontal lines are always parallel to horizontal lines. Vertical lines are always parallel to vertical lines. Vertical lines are parallel to vertical lines, horizontal lines are parallel to horizontal lines. What are they in relation to each other? They are perpendicular to one another. Horizontal is perpendicular to vertical. And here's where, remember how we were talking last week about the equations of those lines? And you were just saying the equation of a vertical line was, what was it again? X equals another. What's the equation of a horizontal line? If a vertical line is x equals a number, what's a horizontal line? Y equals a number. Okay? That's the relationship between the two. So what happens here, if you look, y equals a number is parallel to y equals a number. X equals a number is parallel to x equals a number. Y equals a number is perpendicular to x equals a number. Because horizontal and vertical lines are parallel. Horizontal and vertical lines are perpendicular to one another. That's the relationship we see through a lot of these things. Okay? So as we go around, you might come across some shortcuts from time to time if you have horizontal and vertical. We'll see those as we come across them. But what I want to do is stuff like this. I want to write the equation of the line. Oops. Y equals negative 2x minus 10. That is parallel through the point negative 5. I'm going to write the equation of the line that is parallel through the point negative 5, negative 4. That's parallel to the line negative 2x minus 10. This is what we're going to be doing today. Write equations of lines that are parallel, write equations of lines that are perpendicular. Yes, ma'am? Nope. It's not, does this ordered pair land on this line? This is a completely different setup. Okay. So when we're trying to write the equations of lines that are parallel, or we're trying to write the equations of lines that are perpendicular, we're going to do the exact same thing every single time. It's procedural. Okay. So I always do it up as steps. Step 1. What's the original slope? What's the original slope of that line? Not negative 2x, just negative 2. Okay. First thing we always do is identify and figure out what the original slope is. Okay. In this case, the original slope is negative 2. Second step. Is it a parallel slope problem? Or is it a perpendicular slope problem? Which one is it? Parallel. It's a parallel slope, so what is the parallel slope to negative 2? Negative 2. Okay. Third, and this is kind of where you were getting at with the write the equations of the lines. I have a slope and a point. I use point slope form. And solve for y. Once you identify what the slope that you have to work with, the negative 2, and then you're using the ordered pair that they give you, negative 5, negative 4. Substitute in, solve for y. Becomes the exact same thing we've been doing for a few days. Yes, ma'am. Yeah, and the reason why I do that is that way it makes you reread the instructions. A lot of times people forget to read the instructions. You'll do 2 problems in a row that are parallel, and all of a sudden you think every problem's parallel because you didn't read that next question said perpendicular. That's why I always throw that as my second step. It just forces me to go back and reread. Okay. So now you fill in the blanks. Y minus a negative 4 equals negative 2 times x minus a negative 5. I'm just direct substitution for what we have. But remember what we did. Minus and negative, what do we always rewrite that as? Plus. Very good. So I'm going to rewrite this one time. Do y plus 4 equals negative 2 times the quantity x plus 5. Solve for y. Distribute. You get y on the side. So we have negative 2x minus 10. And then how do I move a positive 4? And you wind up with y equals negative 2x minus 14. Bless you. Yeah. What's that? Okay. That's the idea. We're just going to go through the same 3 steps each and every time. And we just keep doing it. You read it, tells us what to do, then we go on. It will tell you in the instructions. It tells you in the instructions. Okay. Let's try another one. What did I have? It'll look like it won't put the parallel symbol in there. It'll say parallel to. Parallel to a point. Something along those lines. And again, I'm just going to keep doing the same steps. First thing, what's the original slope? Second thing, is it a parallel slope problem or is it a perpendicular slope problem? And then thirdly, I use point slope and I solve for y. I do this over and over and over. So in this problem here, what's the original slope? Negative 1/2. Very good. So I write that down. My first step, the original slope. Step 2, is it a parallel problem or is it a perpendicular problem? Which is it? Parallel. So if it's parallel, what's a parallel slope to negative 1/2? Negative 1/2. Point slope. Y minus 0 is negative 1/2 x plus 2. And you're using the ordered pair that they give you. You start filling in blanks. Okay. Start filling in blanks. So, we'll distribute out. We had y equals negative 1/2 x minus 1. You're done. Your answers will always be written in each slope intercept form. Distribute and solve for y. That's where that comes from. Okay. That's where that comes from. What changes if we have to do a perpendicular? Change the slopes. Really all I gotta do. For example, if I have the equation y equals negative 2x minus 4, and I want to be perpendicular to, excuse me, negative 4 and 6. Again, it'll say write the equation of the line that is perpendicular to the given line through the given point. It'll say a bunch of words similar to that. And you just follow the steps. Very first step. What's the original slope? What's the slope of this equation? -2. Okay. Second step, is it a parallel slope problem or is it a perpendicular slope problem? It's perpendicular. Good. If it's perpendicular, what's perpendicular to -2? 1/2. Very good. Perpendicular slope is just 1/2. It's the opposite reciprocal. And thirdly, we just take our values, substitute in your y or your point slope form. We had an ordered pair of -4 and 6, so it's y minus 6 equals 1/2 x plus 4. And again, the reason why I'm writing it as plus 4 is that way I didn't have to write minus and negative. If you were on your phone, you would have it written down faster. So distribute out and solve for y. So what's half of 4? And then add 6. Sorry about that 8 there. It's that fast. It's the same thing over and over. Okay. Next. Write the equation of the line that is perpendicular to 1/6x plus 2 through the point -3 and -1. What's the original slope? 1/6. Is it a parallel slope problem or is it a perpendicular slope problem? Okay, it's perpendicular. What's perpendicular to 1/6? -6. -6. And lastly, fill in the blanks. Y plus 1 is -6, x plus 3. Subtract 1. And y is -6x minus 19. Procedural. Follow the exact same process each and every time. And that's how this stuff works. It's the idea that we understand what parallel means, what perpendicular means. The weirdness comes in when they start talking about horizontal and vertical lines. And that's where most of you guys always seem to make mistakes. Okay. For example, if I say that we have a line y equals 6, and I want to be parallel to the ordered pair 2, 3. Y equals 6. What kind of line is it? It's horizontal, okay? It's a horizontal line. So this is a horizontal line. What kind of lines are parallel to horizontal lines? Horizontal lines. The equation of every single horizontal line is y equals a number, correct? Okay. In the ordered pair, what does y equal? 3. Your answer is because every line that's horizontal has the same equation. Y equals a number. What does y equal in that ordered pair? 3. Where's your answer? Y equals 3. That's it. Why? You can go the long way. What's the slope? What's the original slope? When you're dealing with horizontal and vertical lines, do it this way. You have to think about what does it mean? What is the equation? What does it look like? That's the easiest way to do it, instead of trying to figure out slopes and using formulas and all that. This works very well with these types. Same thing if it's vertical. If you have x equals -4, and I want to be parallel through the ordered pairs -2 and 5. Good. It has to be x equals -2. Because what kind of lines are parallel to vertical lines? Put away your phone. Thank you. What kind of lines are parallel to vertical lines? Vertical lines. What's the equation of every single vertical line? X equals a number. Well, in order to be parallel to that point, what's the x value equal in that point? -2. Answer is -2. If it was perpendicular, okay? Now let's watch what happens if they're perpendicular. If you're talking about perpendicular, let's say we start with x equals 5, and I want to be perpendicular to the ordered pair 2, 6. What kind of line is x equals 5? Which is it? It's vertical. Good. X equals a number is vertical. What's perpendicular to vertical? Horizontal. What's the equation of every single horizontal line? Y equals. What does y equal here? 6. Make sense? Here it goes there. Okay. Because horizontal and vertical lines are perpendicular to one another. That was that whole thing that we wrote out. Remember we wrote it out a couple days in a row. We did it again today. Slopes of horizontal lines are 0. Slopes of vertical lines are undefined. Those two slopes are opposite reciprocals. They're perpendicular to one another. They're perpendicular. That's why this works. Oh, excuse me. Take a minute to do it. Please. through. What's the original slope? Good. Your original slope is negative 2/3. Which is it, a parallel or perpendicular problem? Okay, perpendicular. What's perpendicular to a negative 2/3? 3/2, very good. Then lastly, point slope form. And fill in the blanks. Y minus 2 is 3/2 x minus 6. Press a couple buttons on the calculator when you're moving stuff around. I think you get 9. So it's y minus 2 is 3/2 x minus 9. And then how do you move the negative 2? Add it over. Very good. We get y equals 3/2 x minus 7. And you're done. Yeah, I was very, very busy weekend. Baseball, soccer, mow your yard, family stuff, this, grocery shopping, Costco. All right. Okay. Try that one. What's the original slope? Which is it, parallel or perpendicular problem? What's parallel to negative 4/3? Negative 4/3. Point slope. And fill in the blanks. Was it 3, negative 4? So y plus 4 is negative 4/3 x minus 3. Distributing, you get what, x plus 4? I'm sorry, negative 4/3 x plus 4. And then what do I do with that? Subtract it over. And you're just left with y equals negative 4/3 x. You're done. Just happens to have a y-intercept of 0. That's fine. Okay. What's up? No, I saw yours. Saw yours first. I should say. Sure. Yes, sir. If it was perpendicular, yes, it would be 3/4. Very good. Yep. That's all you need. Just flip the fraction, change the sign. These all parallel, one perpendicular. I just changed that perpendicular. Okay. Excuse me. So we want to be perpendicular through negative 1, negative 5 for the equation y equals 5x plus 1. Now that's one you got to be careful with because you're going to have some fractions here. That's why I use the fraction button on the calculator, the fraction bar. It'll help you get to the fractions correctly. No decimals, never a decimal. I don't want decimals. Yeah, and yeah, these are lines. Lines can have negative slopes and stuff. What's the original slope? 5. Is it a parallel or perpendicular problem? Perpendicular. How do we know that? Because it said so. What's perpendicular to a slope of 5? Negative 1 over 5. Very good. Use point slope. Use point slope then. Was it y plus 5 equals negative 1/5 x plus 1. And again, the reason why it's plus 5 plus 1 is because instead of writing minus or negative, we just automatically switch it to a plus. Distribute into the parentheses. And then how do you move a 5? I subtract it. Hello again. What do you got? I'm sorry. Oh yes, I went to go print that. But yeah, I printed out the other one. Thank you. And then in the calculator, if you put that through, you get what, negative 26 over 5? Perfect. And that's fine. And that's what your fraction should look like. Press the buttons in the calculator, and that's what it'll do. No mixed numbers. Mixed numbers are awful. Mixed numbers are awful. You know? One of the reasons why we don't really use mixed numbers, we don't use them. They're not very useful in upper level math, and that's why as you get further along, there's a time and a place to use them. But more often than not, for us, it's much easier to have top-heavy fractions because you can add, subtract, multiply, divide top-heavy fractions quicker than you can with mixed numbers, and that's where we head towards. Right? If I am not mistaken, I already posted the homework problems on the calendar. I think there's like eight or so. Did I or did I not? I thought I did. Yeah, I thought I put those on there. Let me double check. But I'm pretty sure I did. I think there's only like, I don't think there's that many. Yeah, I put them on there. I am putting it down there as we speak, sir. There they are. All right. Go ahead and get started on those then, please.